Subscribe so you can keep building your certification skills with new practice videos every week. Visit cloudcertificationstore.com for weekly releases and complete practice sets. Welcome back to the playlist. Episode 3 of 15 continues the AWS Certified AI Practitioner, AIF-C01, practice series with questions 21 through 30. Let's begin the next round. Question 21. Which phase of the ML lifecycle determines compliance and regulatory requirements? Option A, feature engineering. Option B, model training. Option C, data collection. Option D, business goal identification. The correct answer is D, business goal identification. Explanation. Compliance constraints shape data handling, model choices, and deployment architecture. Capturing them early prevents costly redesigns and audit gaps later. This is part of defining success criteria alongside KPIs and stakeholders. Hence, the determination occurs at the goal-setting phase. Why not option A? Feature engineering. This applies constraints but doesn't define them. By this stage, requirements should already be known and enforced. Waiting until FE can lead to rework and non-compliance. Therefore, it's too late. Why not option B? Model training implements a plan. It shouldn't discover compliance needs. Changes here are expensive and risky. Compliance must inform training data, metrics, and controls beforehand. Thus, not the right phase. Why not option C? Data collection follows the rules. It doesn't author them. If requirements are discovered only here, data could be mishandled. Proper governance dictates setting requirements before collection begins. Hence, it's downstream. Question 22. A food service company wants to reduce daily food waste and increase revenue, continuously improving model accuracy. Which solution meets these requirements? Option A. Use Amazon SageMaker and iterate with newer data. Option B. Use Amazon Personalize and iterate with historical data. Option C. Use Amazon CloudWatch to analyze orders. Option D. Use Amazon Recognition to optimize the model. The correct answer is A. Use Amazon SageMaker and iterate with newer data. Explanation. Continuous retraining on fresh data captures seasonality and shifting demand patterns. SageMaker provides pipelines, schedulers, and ML ops tools to automate improvement cycles. This approach measurably enhances forecast accuracy over time. It aligns directly with the continuous improvement requirement. Why not option B? Amazon Personalize with historical data. Personalize is for recommendations, not this broader optimization. Relying only on historical data misses evolving conditions. It does not ensure continuous retraining tuned to waste reduction. Hence, misaligned. Why not option C? CloudWatch to analyze orders. CloudWatch is for monitoring and alerting, not model training. It can collect metrics but won't retrain or deploy better models. Using it alone won't improve accuracy. Therefore, it's insufficient. Why not option D? Recognition is for visual analysis, unrelated to demand/waste forecasting. It doesn't operate on order time series or optimization objectives. Applying it would not address the problem. Thus, not applicable. Question 23. A company has a trained model for real estate price prediction and wants serverless, managed hosting for online inference. Which solution meets these requirements? Option A. Amazon EC2. Option B. Amazon EKS. Option C. Amazon CloudFront Plus S3. Option D. Amazon SageMaker and Point. The correct answer is D. Amazon SageMaker endpoint. Explanation. SageMaker endpoints provide fully managed, auto-scaled real-time inference with a /B and canary options. You avoid managing servers, containers, or orchestration. It integrates with monitoring and model registries for governance. This matches the serverless, production inference requirement. Why not option A? EC2 you must manage instances, scaling groups, patching, and deployment. That increases operational overhead. It contradicts the no servers to manage requirement. Hence, not ideal. Why not option B? Kubernetes brings powerful orchestration but requires cluster and node management. Maintaining manifests, autoscalers, and observability adds complexity. It fails the minimalops constraint. Therefore, not the best fit. Why not option C? CloudFront plus S3 excellent for static content, not dynamic ML inference. It cannot execute model code or return predictions. You'd still need a back-end compute layer. Thus, it doesn't meet the requirement. Question 24. A company wants to use generative AI to increase developer productivity and will use Amazon Q Developer. What can Q Developer do? Option A. Create software snippets, track references, and handle OSS license tracking. Option B. Run applications without provisioning servers. Option C. Enable voice commands for coding and natural language search. Option D. Convert audio files to text documents. The correct answer is A. Create software snippets, track references, and handle OSS license tracking. Explanation. Amazon Q Developer generates code suggestions grounded in documentation and examples. It can cite sources and help manage open-source licensing implications. These capabilities directly accelerate coding tasks while maintaining compliance. That aligns with developer productivity goals. Why not option B? Run applications serverlessly that describes AWS Lambda or serverless compute, not Q Developer's function. Q Developer integrates in the IDE and repos, not runtime hosting. Mixing these concerns would mislead architecture decisions. Thus, incorrect. Why not option C? Voice commands plus NL search. While some tools offer voice control, Q Developer's core value is code generation and guidance. Natural language search exists in other services, e.g., Q Business. But this answer overgeneralizes. It doesn't capture Q Developer's primary strengths. Therefore, not the best description. Why not option D? Audio to text. That's Amazon transcribes domain. Q Developer doesn't focus on speech-to-text pipelines. Conflating services could complicate solution design. Hence, it's not applicable. Question 25. A company needs an AI app to let employees check open claims, identify details for a specific claim, and access documents. Which solution meets these requirements? Option A. Agents for Amazon Bedrock plus Amazon Fraud Detector. Option B. Agents for Amazon Bedrock plus Bedrock Knowledge Bases. Option C. Amazon Personalize plus Bedrock Knowledge Bases. Option D. Build a new custom model in SageMaker. The correct answer is B. Agents for Amazon Bedrock plus Bedrock Knowledge Bases. Explanation. Bedrock Knowledge Bases ingest and index documents for retrieval during conversations, RAG. Agents orchestrate tool calls, enabling navigation, lookups, and retrieval grounded in company data. Together, they deliver a conversational UI that can find claim details and documents. This minimizes custom training and speeds delivery. Why not option A? Agents plus Fraud Detector. Fraud Detector scores potential fraud. It doesn't retrieve claim documents. It adds cost and complexity without addressing the core retrieval use case. The requirement is knowledge access, not fraud analytics. Thus, it's misaligned. Why not option C? Personalize plus knowledge bases. Personalize provides recommendations, not conversational orchestration. It won't chain tools or maintain dialogue state for claims lookup. Agents are the appropriate coordination layer. Therefore, C is not suitable. Why not option D? Build a new model in SageMaker. Training a custom model is expensive and unnecessary for document retrieval and QA. Bedrock's Agent plus RAG pattern meets needs with far less effort and risk. Custom training should be reserved for unmet capabilities. Hence, D is not cost-effective. If you want more practice like this, subscribe for weekly certification videos and guides. Preview weekly releases and complete practice ebooks at cloudcertificationstore.com. Question 26. A manufacturing company uses AI to inspect products and find any damages or defects. Which type of AI application is the company using? Option A, recommendation system. Option B, natural language processing (NLP). Option C, computer vision. Option D, image processing. The correct answer is C, computer vision. Explanation. Computer vision models analyze visual inputs, images/videos, to detect objects, anomalies, and defects. They leverage architectures like CNNs/transformers to localize and classify issues on production lines. This directly supports automated quality inspection at scale. The use case is about understanding image content, not merely transforming pixels. Why not option A? Recommendation system designed to predict user preferences and suggest items, not inspect visuals. It uses behavioral signals, clicks, purchases, unrelated to product imagery. Applying it here would not yield defect detection capabilities. Therefore, it's misaligned with the task. Why not option B? Natural language processing (NLP) focused on text processing, tokenization, sentiment, Q&A, not images. NLP lacks primitives for spatial features like edges, textures, or shapes. It cannot interpret visual defects without a vision bridge. Hence, not applicable. Why not option D? Image processing refers to low-level pixel operations, filtering, resizing, not semantic understanding. It improves image quality but does not recognize defects. You still need computer vision to infer meaning. Thus, it's insufficient on its own. Question 27. A company wants to create an ML model to predict customer satisfaction and needs fully automated model tuning. Which AWS service meets these requirements? Option A, Amazon Personalize. Option B, Amazon SageMaker. Option C, Amazon Athena. Option D, Amazon Comprehend. The correct answer is B, Amazon SageMaker. Explanation. SageMaker supports automatic model tuning, HPO, to search hyperparameters efficiently. It orchestrates parallel trials and selects the best configuration against a metric. This reduces manual effort and accelerates convergence. It's a native fit for automated tuning needs. Why not option A? Amazon Personalize optimized for recommendations, not general-purpose HPO across arbitrary models. Its tuning is domain-specific and does not expose broad HPO workflows. Using it for satisfaction prediction would be constraining. Therefore, not ideal. Why not option C? Amazon Athena, a serverless query engine for data in S3. It doesn't train or tune models. It can prepare data but cannot automate HPO. You'd still need SageMaker or similar for modeling. Hence, it's not the right tool. Why not option D? Amazon Comprehend provides pre-built NLP tasks, entities, sentiment with limited custom training. It's not a platform for automated hyperparameter tuning across models. For bespoke prediction tasks, it falls short, thus not suitable. Question 28. Which technique can a company use to lower bias and toxicity in generative AI applications during the post-processing ML lifecycle? Option A, human in the loop. Option B, data augmentation. Option C, feature engineering. Option D, adversarial training. The correct answer is A, human in the loop. Explanation. Human review can filter, edit, or block unsafe outputs before they reach users. It provides targeted feedback that can later inform model prompts or guardrails. This approach works immediately without retraining the model. It's a pragmatic post-generation control. Why not option B? Data augmentation acts during training to rebalance or enrich datasets, not after inference. It can reduce bias long-term but doesn't moderate live outputs. For immediate post-processing needs, it's ineffective. Thus, not the right stage. Why not option C? Feature engineering, also a pre-training/pre-inference step to transform inputs. It won't evaluate or edit generated text for toxicity after the fact. Post-processing requires output filters or human checks. Hence, misaligned. Why not option D? Adversarial training involves retraining with adversarial examples to improve robustness. It's costly and not a post hoc filter for live responses. The question targets post-processing, where HITL fits best. Therefore, D is unsuitable here. Question 29. A bank fine-tuned an LLM for loan approvals and found faster approvals for one demographic. How should the bank fix this most cost-effectively? Option A. Add diverse data and refine-tune. Option B. Use RAG with the fine-tuned model. Option C. Use AWS Trusted Advisor checks. Option D. Pre-train a new LLM from scratch. The correct answer is A. Add diverse data and refine-tune. Explanation. Bias often stems from non-representative fine-tuning sets. Adding balanced examples addresses it directly. Refine-tuning is cheaper than pre-training and targets the decision boundary you control. You can incorporate fairness constraints or reweighting during this step. It offers a practical path to measurable mitigation. Why not option B? RAG retrieval augments factual grounding but doesn't change the model's internal bias in classification. It helps with knowledge access, not parity of treatment. The observed disparity persists without adjusting learned parameters. Hence, not a fix. Why not option C? Trusted Advisor focuses on cost, security, and best practice checks for AWS resources, not ML fairness. It won't inspect or remediate decision bias in an LLM. Using it won't change model behavior. Therefore, irrelevant to the problem. Why not option D? Pre-train a new LLM, extremely expensive and unnecessary when the issue lies in domain adaptation. Fine-tuning with balanced data achieves most benefits at a fraction of cost. Starting over has poor ROI and long timelines. Thus, not cost-effective. Question 30. A company wants a customer service chatbot using company policies as knowledge with minimal cost. What's the best approach? Option A. Retrain the LLM on policy data. Option B. Fine-tune the LLM on policy data. Option C. Implement RAG for in-context responses. Option D. Use pre-training with data augmentation. The correct answer is C. Implement RAG for in-context responses. Explanation. RAG retrieves relevant policy snippets at query time, avoiding training costs. It scales as policies change, Update the index, not the model. It also reduces hallucinations by grounding answers in source documents. This balances cost, freshness, and quality. Why not option A? Retrain full retraining is prohibitively expensive and slow for document updates. It locks knowledge into weights, complicating version control. It's overkill for a document QA use case. Hence, not optimal. Why not option B? Fine-tune cheaper than retraining but still incurs training/storage overhead. It also risks overfitting to policy phrasing and staleness over time. RAG keeps knowledge external and maintainable. Therefore, B is less cost-effective. Why not option D? Pre-training with augmentation. Pre-training is massive scale and misaligned with the scope task. Augmentation won't fix the need for continuously updated context. This route adds complexity without commensurate benefit. Thus, not advisable. That's all for this episode. Follow Get It Done Certified for more practice content and help another candidate by sharing this series with them. The next episode in the playlist is ready when you are.